Hello everyone, you're welcome to Zishan classes. Today we're gonna look into another question from the chapter Kinematics. We have already looked into a lot of questions from the same chapter, and I think this question and a group of these questions, which is around 4 or 5 of them, there are around 4 or 5 of them which are very important and are very interesting. These need to be addressed, and that is why I'm picking up these questions. The coming 4 videos are going to be about mass pulley systems. Okay, so the system here is that we have a large mass M and a small mass small m, and the arrangement is like this. There are 2 pulleys attached to capital M, and there is a fixed support out here for the thread. What we have to do is we have to find the acceleration of the mass M with respect to the horizontal surface. The friction exists only between these 2 masses. There is no friction here on the surface. We have to calculate the acceleration of the small mass M with respect to the floor on which the wedge M rests or slides. There are a few points that you need to understand to start this question. The first point is that this small mass M is going to come down. Result of which is that this thread is going to be pulled down, this part pulled up, and this part being fixed to this support is finally going to pull the capital mass M to the right. M comes down and capital M moves to the right. This one thing you need to understand. Another thing which is very, very important in all the coming questions. You'll find various applications of the same concept in the coming questions. The point is that for every inch this M moves down, the same distance is going to be moved by the capital mass M to the right. If this moves 1 inch down, this moves 1 inch to the right, which leads us to the conclusion that the acceleration of the mass M in downward direction is equal to the acceleration of the wedge capital M in the right direction. Also, the third thing that you need to understand is that the small mass M has 2 accelerations being imparted to it, one moving downwards, one pulling it downwards, and the other one is due to the capital mass M, which is also taking it along with it to the right. So the small mass M is facing 2 accelerations, one this way, another this way. This is equal to A. This is also equal to A, the reason of which I've explained earlier. It moves down, this moves that way. This moves to the right. So, small mass M has 2 accelerations. The resultant of which is obviously going to be equal to root 2A. This concept here you need to keep in mind before starting anything with this problem. Rest, everything is just simple maths and free body diagrams and equations and everything. So, this is how we are going to sum up the whole problem here. Rest, everything is fine. It's just simple maths. So, you need to keep these in mind. If you want to listen to it, you can obviously replay it in your YouTube channel and understand it. Also, talking about YouTube, please subscribe to the channel. Also, if you need any kind of assistance through Zoom classes, you can contact me, tell me in the comments, we will have a chat about it and we'll make an arrangement about it. Okay, so for now, we'll continue with the problem. We'll start with the free body diagram of these two bodies, and these 2 points you need to note down. I'll write it here. I'll write it here. The small mass m, it has 2 accelerations, one this way, one this way. The resultant of which is root 2a. That's it. We'll continue with the problem now. So these are the forces acting on the body. Capital M, the wedge. Reaction by the floor, mg, its own weight. Reaction by the small mass m kept here. Mu r is the friction applied by the small mass m downwards. Tension this way, tension upwards, and these 2 tensions because of the rope on the pulley. We will write the equations for this wedge. Keep in mind, the only forces responsible for the motion of the capital M wedge are this and this 2 forces. Rest of it are not relevant for the motion. So we are going to use this concept to write the equation for the capital mass M. So it's going to be T minus R is equal to MA. Simple. There's nothing else. We're gonna name this first equation. Rest we don't need to write. You draw this diagram with you in your copy. You also write this equation. We'll move on to the small block M. Talking about the small mass M. It's moving downwards. Friction is going to act up. It was placed on the wedge. Reaction is going to be directed this way. mg downwards. It was attached to a rope. The tension up. Now, this body has 2 accelerations, this way and this way. We will write equations separately for both of them. How are they going to look like? Talking about the acceleration this way, the only force responsible for the acceleration in this direction is the reaction R. So we have R is equal to MA. Also, if we talk about the acceleration downwards, the equation is going to look like mg minus t minus mu r equals ma. Okay. We will write these 2 here. R equals ma. Name it 2. mg minus t minus mu r is equal to ma. Name this 3. And we will solve these 3 equations for the value of a. Putting r equals to ma here, we get, putting r equals to ma from the equation 2 in the equation 1, we get t is equal to m plus m times a. Putting the value of t from here in the equation 3, we get mg minus m plus m times a minus mu r. R is equal to ma. ma equals ma. Solving this for a, we will come to a is equal to mg divided by m plus m times mu plus 2. A is equal to mg divided by m plus m into mu plus 2. You can divide both the numerator and denominator with small m. You'll get at m by m plus mu plus 2. Acceleration. Now we have come to the last part of our problem. Acceleration nay. Talking about the small mass m, there were two accelerations, the value of which we have already got. I told you the resultant of these two, it's going to be root 2a. So the acceleration that was required, am, will be equal to root 2 times a, which we have already got, m by m plus mu plus 2. So this is it, the acceleration of the small mass m with respect to the floor. We end up here. This was one very interesting question. Now we're gonna move to another one. Meet you in the next video. See you. Have a good day. Bye.